In this lesson, we're going to graph quadratic functions. A quadratic function is in the form y equals x squared. This is known as the parent function. Quadratic functions take the shape of a parabola. In vertex form, the vertex of our function can be seen from the equation. Y equals a parentheses x minus h squared plus k. The h and the k in the equation give me the vertex. So when a quadratic function has a minimum value, this is a positive graph. The vertex is at the bottom, the h is -1, and the k is -4. Or if the vertex is at the top of the graph, this gives us a maximum value. And in this example, h is 1 and k is -1. The axis of symmetry is a vertical line that goes through the vertex, and it cuts my graph in half left to right. So the two sides mirror each other. The axis of symmetry is a vertical line, so the equation is x equals, and it goes through the x value of the vertex. So let's practice graphing some of these. My problem, graph the translations of f of x equals x squared. Translations is just another way of saying movement. So I'm going to take the parent function, whose vertex is at 0, 0, and I'm going to move that graph left, right, up, or down. The first thing I want to do is find out what the vertex is. My vertex form, y equals a, x minus h squared plus k. So h goes along with the 3, and k is the 2. This x minus h, that's the same thing as the opposite of h. So my vertex is the opposite of 3, -3, and k is +2. So I'm going to plot that point, -3, +2. Axis of symmetry is the line that I can draw through the vertex, and I know that whatever point I put on the left side, I can mirror the same point on the right. So my axis of symmetry goes through x equals -3. I need one more point in order to plot the parabola. I'm going to select it at the y-intercept. The y-intercept is this line everywhere that x is equal to 0. So I can take x equals 0 and plug it into the original equation to find out what y would be. So when x equals 0, y equals 0 plus 3 squared plus 2. 3 squared is 9, plus 2 gives me 11. So my x-intercept is at 11. I had to extend my graph, and that's the point on my y-intercept where y equals 11. So my axis of symmetry can be used. I went 1, 2, 3 places to the right to get to the 11. So I can also go 3 places to the left and plot the same point. Now I have my 3 points that I can use to plot the parabola. Or try to plot the parabola. In our next example, we're going to look at just information we can gather by the equation itself without graphing. Identify the vertex, vertex form, so I can look right at the equation and tell what my vertex is. It was a x minus h squared plus k. So h and k were the vertex. Looking right at my graph, this is the opposite of h, so the opposite of -1 will be +1, and k is 3. So my vertex is 1, 3, opposite of what's inside with the outside value. Axis of symmetry is the line that goes through the x value of the vertex. Will this be a maximum or a minimum value? This can be told by the letter A. If A is a positive number, then your graph opens up. I always say positive people smile, so I draw a smile, it opens up. This would give me a minimum value. If A was a negative number, negative people frown, my graph would point upside down, which would give me a maximum value. So in my case, A is positive 2, which means my graph opens up, giving me a minimum. The domain of parabolas is all real numbers. Remember that domain are the x values that you're looking at. The range are the y values that we're looking at. So the range in this case is not all real numbers. We just discovered that this graph has a minimum value. The minimum or lowest point on the graph is at y equals 3. So all the y's on this graph have to be 3 or higher. Y is greater than or equal to 3. So if your graph opens up and it's a minimum, your y has to be greater than the y value of your vertex. In the next example, writing a quadratic function in vertex form, we start with the graph, and now I need to write the equation. Vertex form, let's write what that is again. Y equals a, x minus h squared plus k. So what I need to find are h and k, the vertex, and then the letter a. So looking at my graph, the vertex is -2, 4. Let's put those in for our h and k. I have y equals a, x minus -2, which makes it positive, plus k. Now I still have 3 variables in my equation. What I can do is substitute any x and y from the graph into the vertex form, and that will allow me to solve for a. So I go along my graph, and I find some point that fits exactly on the crosshairs, -4, 0. I could also have chosen 0, 0, but I'm going to do x is -4 and y is 0. So let's put those into our equation. Y equals, so 0 equals a times x is -4 plus 4. Now I can solve for a. -4 plus 2 is -2, and -2 squared is 4. So I have 0 equals 4a plus 4. Subtract the 4 from both sides and divide by 4. A equals -1. So now I have h, k, and a, and I can put it all back to get my final answer. Coming back up to this equation, y equals, a is now -1, x plus 2 squared minus 4. Or you could say y equals negative x plus 2 squared minus 4. And now you can graph an equation in vertex form. You can understand the different parts of the equation and what they tell us. And if you're given a graph, how you write the equation. Hope this helps.